Hi, welcome to another video on continuity, and today we are going to investigate the continuity of a piecewise function. Now, whenever you get a piecewise function, you have to apply a bit of caution because you have to recall that each piece has its own specific domain. So when you look at each piece, you have to determine where that piece has points of discontinuity within its own domain. And when you checked out that for each piece, the next step is to see where the pieces join. That is, each domain will connect to the other domain, and you need to check to see if the value of the function at each piece where the domains connect are the functions going to and include that same value. So that's going to be a plan of attack. We'll investigate one piece at a time. So the first piece, which is going to be 2x minus 2 divided by 2 times the square root of x minus 2. When we look at this piece, we will recognize that within its domain, this piece is always continuous. The point of concern would be when x equals 1, because I would have the indeterminate 0 over 0. But my domain states that x is always greater than 1. So I have no discontinuities to worry about within its domain. But I also need to check to see where this piece goes to when my domains connect. So my next domain goes from minus 2 to 1, and the first domain goes to 1. And therefore, I need to check right at the value of 1. That's where the domains connect. So I'm going to investigate where this function goes to when x goes to 1. So I have to use the limits from here, and because x is always greater than 1, I'm going to have to approach 1 from the positive side. I will factor out my expression to simplify it, to remove that discontinuity. And with a wee bit of algebra, and then I substitute in, I determine that this value, this piece, goes to 2. So I know it itself is continuous, and when x goes to 1, the value of this function will go to 2. So let me just put that aside, and then I will investigate the middle piece. Now, the middle piece says 5 minus 3x, and its domain goes from minus 2 to 1. And now 5 minus 3x is a nice little linear piece, and it's continuous everywhere, including the minus 2 and the 1. So this is very easy function to determine where I'm going to have issues. So I need to check where this piece connects to the piece above it from a domain perspective, and where this piece connects to the piece following it from a domain perspective. In other words, I'm going to have to investigate the 1 and the minus 2. So when x equals 1, this function evaluates to the value of 2. And when x equals minus 2, this function actually evaluates to the value of 11. So this little segment itself is completely continuous, and it goes from a value of 2 to 11, including the 2 and 11. Now let me put this as a summary, and I'll write it in terms of these pieces in terms of limits, so you get to recognize what's going to happen. So the first piece had the limit x goes to 1 from the positive side, and that value was 2, while the second piece had the limit of x went to 1 from the negative side, which also had the value of 2, and f at 1 equals 2. But when this value of this function, when x went to minus 2 from the positive side, it went to 11, and f of minus 2 equals 11. So that summarizes the continuity of the first two pieces and where each of the pieces go to. So to finish off the question, we just have to look at the third segment. That is the third piece. Now, 8 divided by x minus 4. Well, the only point of concern is when x would equal 4. But that's outside the domain, so I never have to worry about x equaling 4. So this little segment, 8 divided by x minus 4, is 100% continuous within its domain. All I need to do now is to see where it joined with the piece above it. That is, I'm going to investigate the function when x goes to minus 2. And I can simply just plug in minus 2 into the expression and determine what value that would be, and it turns out to be minus 4/3. So we're going to put all 3 pieces in a nice little summarized form for us to have a look at. So each piece itself is totally continuous. Yet the first piece, as x went to 1 from the positive side, its value went to 2. Now the second piece had 2 components to be worried about. So when x went to minus 1 from the negative side, it had the value of 2. Also, we discovered that 1 was part of its domain, so f at 1 was equal to 2 for itself. And the other side, when x went to minus 2 from the positive side, in my second piece, it went to 11. But also, minus 2 is within its domain, and its value was also 11. But when we looked at the third piece, that is when x went to minus 2 from the negative side, it went to minus 4/3. So I'm going to look at these things grouped together so that we get a picture. Now, because of the first and the second piece, where they join, and they both joined at x equals 1, and the left side, the right side, and the value of the function all were equal to 2. So we know that the limit exists and the value also exists, and both the limit and the value are the same value, in this case 2. So these 2 pieces actually join at 1, and they join where the value is equal to 2. Yet when we look at the second and the third piece, we'll notice that, yes, from the second piece we have the limit as x goes to minus 2 for the positive side equal to 11, and the value of the function at minus 2 was also equal to 11. But in the third segment, when we looked at its limit when it went to minus 2 from the negative side, its value is minus 4/3. The limit as x goes to minus 2 does not exist between the second and third piece. If it doesn't exist, there is a jump discontinuity at this point. So in other words, this piecewise function is continuously everywhere except where x equals minus 2, where the y value jumps from 11 to minus 4/3. I'll demonstrate this with a little picture, and you can see that on the purple graph, that as x approaches minus 2 from the left-hand side, from the negative side, the function went to minus 4/3. But the green graph says when x approaches minus 2 from the positive side, you can see where it actually went to 11. You can see the actual physical jump between these 2 pieces. Yet between the first function and the second function, you can see as x goes to 1, both of them went to the same value of 2, and we have a joining or a continuous connection between the pieces. Hopefully this example was useful for you, and thank you for watching.